Hello again in my second video. I'm Dr. Borak Basadia, Assistant Professor at Faculty of Science and Technology in Jalfa University. In last video, I have represented the material that I have assigned to teach, chemistry of elements. In this video, I will address the second chapter, the structure of the atom. These chapters spread over 3 weeks and subjected to individual continuous evaluation. An atom is the fundamental unit of matter. It's the basic building blocks of matter that cannot be divided into smallest parts. It forms different elements, ions, compounds, and molecules essential to life. In fact, the atom does not often exist in free state. It combines with others to form molecules. We have the monoatomics like the noble gas, helium, argon, and diatomic like the hydrogen and oxygen, and polyatomic like the water. The name atom coming from the word atomos, which means not to be cut. This word coming from the Greek philosopher Democritus. Democritus is the first one who proposed the idea of atom. In early 1800, the chemist John Dalton performed a number of experiments that eventually led to the acceptance of the idea of atoms and became the foundation of modern chemistry. His theory was the first based on scientific evidence. The atom contains 3 basic particles, namely proton with positive charge and neutrons, which are neuter, and both compose the nucleus of the atom. The electrons are located at the outermost region called electron orbits. Performed number of experiments are eventually led to discovering the constituent of atom. First, the experience of G.G. Thomson, followed by the experience of Millikan's oil drop and Rutherford's experience. In 1897, the scientist G.G. Thomson performed his first experience to discover the electron. Under the effect of very high electrical voltage applied between 2 internal parts of discharge type, a beam is emitted from the cathode. This cathode call it cathode rays and collected by the anode. This cathode ray propagates in rectangular manner and perpendicular to the cathode, and they are made up of particles that transport energy. These cathode rays are deflected by an electric pile towards the positive pole, which indicates that the particles constituting these rays are negatively charged. The scientist Stoney gave the name electron for the particles constituting these cathode rays. Millikan's drop experiment was an experiment performed by Robert Millikan and Harvey Blankter in 1909 to measure the charge of an electron. In this experiment, the oil is passed through the atomizer from where it comes in the form of tiny droplets. They pass the droplets through the holes present in the upper plate of the apparatus. The downward motion of droplets are observed through the microscope and the mass of oil droplet and then measure their terminal velocity. The air inside the chamber is ionized by passing a beam of X-rays through it. The electric charge on these oil droplets is acquired by collision with the gaseous ion processed by ionization of air. The electric field is set up between 2 plates, and so the motion of charged oil droplet can be effected by the electric field. Gravity attracts the oil in a downward direction, and the electric field pushes the charge up where the strength of the electric field is regulated so that the oil droplet reach in equilibrium position with gravity. The charge over the droplet is calculated at equilibrium, which is dependent on the strength of the electric field and the mass of the droplets. The charge over any oil droplet is always in integral value of E equal 1.6 multiplied by 10 minus 19. Hence, the conclusion of Millikan's oil drop experiment is that the charge is said to be quantized. For example, the charge on any particle will always be in integral multiple of E. The experiments of Thomson and Millikan allowed us to determine the charge E and the mass of electron. 1998, Ernest Rutherford made his experiment for discovering the nucleus of atom. His experiment consists of bombarding a very thin sheet of metal with radiation made up of helium. According to Rutherford, all atoms are composed of a positively charged central nucleus. The core contains two types of ingredient particles: proton, which are positively charged, and neutron, which are neutral. The atom mass is concentrated in the nucleus. To identify the element, we associate a symbol with each chemical element X. It is written in capital letters. For example, hydrogen, oxygen, and carbon, or followed by the lower case, for example, chlorine, calcium, and copper. The element is represented by A, mass number. This designates the number of proton and neutron, and atomic number or charge number. It is designates the number of proton. From the previous point, we noticed that the atoms of an element have characteristic average mass which is unique to that element, and the atoms of any one element differ in properties from atom to another element. The atoms cannot be subdivided, created, or destroyed in ordinary chemical reactions, and the changes in atoms can occur in nuclear reactions. We distinguish two types of atoms, non-isotope and isotopes. The isotopes are two or more types of atoms that have the same atomic number, which is the number of protons, and have the same position in the periodic table, but have different number of neutrons in their nucleus. In this chapter, we have covered the essential paths of chemistry of element, where I have teach you the four conceptual important questions. What is an atom? What is an atom made of? How the atom is discovered, and why atoms are different. We have reached the end of this video. Thank you very much for your attention.